A pleasant day, mathletes. I'll be your math teacher for today. I will walk you through the simplest possible way of understanding today's lesson. Feel free to pause the video to jot down important concepts. Forget everything you know about numbers. In fact, forget you even know what a number is. This is where mathematics starts. Instead of math with numbers, we will now think about math with things. Our lesson for today is all about sets. So, at the end of this lesson, you are expected to be able to describe and illustrate well-defined sets, and also define sets using different ways. A set is a list or collection of well-defined objects or ideas. Well, simply put, it's a collection. First, we specify a common property among things, and then we gather up all the things that have this common property. For example, the items you wear: hat, shirt, jacket, pants, and so on. I'm sure you could come up with at least 100. This is known as a set. Or another example is types of fingers. This set includes index, middle, ring, and pinky. So, it is just things grouped together with a certain property in common. And those things that were grouped together with a certain property in common, or the objects in a set, are called the elements or members of the set. Let's say, for example, which of the following collections are set? Is it the past presidents of the country, or the good players who have played for the national team? I'll give you 5 seconds to think. Time's up. Let's see. Is the past presidents of the country a set? Yes, it is a set because it is well defined. How about for the good players who have played for the national team? Is it a set? No, it's not a set because we are not given the criteria whether the player is good or not. We actually define a set via verbal description, roster method, or rule method or set builder notation. Let's say, for example, the set of vowels in the alphabet. For the verbal description, the answer would be the set of vowels in the alphabet. For the roster method, the elements are put inside a set bracket or a brace and is separated by a comma. So the answer would be A, comma E, comma I, comma O, comma U. You can also define it by its properties, and that is by using the rule method or set builder notation. So in this case, the answer is going to be the set of all x's such that x is a vowel in the alphabet. Always take note that sets are usually denoted by capital letters such as A, B, C, and so on. Also, the symbol epsilon or negated epsilon are used to indicate that an object is or is not an element of a set respectively. For example, if S represents the set of all flowers, then rose is an element of set S, and mango is not an element of set S. At the start, we used the word things in quotes. We call this the universal set. It's a set that contains everything. Well, not exactly everything. Everything that is relevant to our question. Meaning to say, universal set or universe is the set that comprises all elements being considered in a particular discussion. This is probably the weirdest thing about sets. As an example, think of the set of piano keys on a guitar. But wait, you say, there are no piano keys on a guitar. And right you are. It is a set with no elements. This is known as the empty set.
There aren't any elements in it, not one. It is actually represented by a slashed zero or by a brace, meaning it is a set with no elements.
Well, the cardinality of sets, or also known as the order, refers to the number of elements in a given set. Let's say, for example, set A has the elements 10, 20, 30, and 40. Therefore, set A has a cardinality of 4, or it has 4 elements, or it could also be written as. And now let's dig deeper. Let's talk about other symbols, notations, and also the Venn diagram, which is used in describing a set.
It is actually a diagram that makes use of geometric shapes to show relations between sets. Examples are as follows. The union of sets has this symbol. If you see this symbol, it means you have to combine all elements of the sets, but elements should not be repeated. We can show that in a Venn diagram. Let's say, for example, we have set A and set B. If we're going to combine all the elements of set A and set B, then we have a union of sets A and B. Let's say, for example, we have to find the union of sets A and B, and also its cardinality. The given are sets A and B, where set A has elements 1, 3, 5, 7, and 8, and set B has elements 2, 3, 6, 7, and 9. If the union of sets means combining all elements of the sets but elements should not be repeated, therefore, the union of sets A and B is equal to 1, 2, 3, 5, 6, 7, 8, and 9, written as follows. And the cardinality of a union of sets A and B is equal to 8, meaning there are 8 elements in the union of sets A and B. Well, the intersection of sets has this symbol. When you see this symbol, it means all the elements that are common to both sets. In a Venn diagram, if we have set A and set B, and if we're going to get the common elements of set A and set B, then that is going to be the intersection of sets A and B. Let's say, for example, we have to find the intersection of sets M and N, and also its cardinality. The given are sets M and N, where set M has elements 1, 3, 5, 7, and 8, and set N has elements 2, 3, 6, 7, and 9. If intersection of sets means all sets must be common to both the given sets, therefore, the intersection of sets M and N is equal to 3 and 7, and its cardinality is equal to 2, because there are only 2 elements in the intersection of sets M and N. It's the complement of a set, which has an apostrophe symbol. These figures shows complements of a set. This means all elements in the universal set that is not found in the set. It is a special way of saying everything that is not. Let's say, for example, find the complement of set F. We have a universal set with elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We also have set F with elements 2, 3, 6, 7, and 8. In order for us to find out elements that is not included in set F but is included in a universal set, we have to cross out the common elements of both sets. Since the element 2 is common to both the universal set and set F, we have to cross it out. Same goes with 3, 6, 7, and 8. And what remains is the complement of set F. Therefore, the elements of the complement of set F are 1, 4, 5, 9, 10, 11, and 12. And it is shown in this illustration of its Venn diagram. Well, that is all for today. Thank you for listening. I hope you have learned a lot. Have a great day.